Hello folks, greetings. So today we are going to continue with our journey on antiderivatives. I know that the last time we looked at how, given a graph of a derivative, can you find the original function, which is the antiderivative, right? Today we are going through certain formulas of finding antiderivatives. In other words, that if the derivative is something, what is the antiderivative, right? And the best way to get these formulas is very simple, right? If somebody says that, hey, this is a derivative, this is basically a derivative of a function, then all you got to do is, and then say that, hey, this is the antiderivative. How do I know if that is the antiderivative? All you got to do is find the derivative of the antiderivative to find out, yes, that checks out well, okay? But there are some formulas that you'll have to remember, and these are easy to remember actually. And if you remember these formulas, then it's very, very easy for you to deal with these antiderivative exercises that I think we are going to deal with today. Okay, let's start with the simplest of simplest formula. So if somebody says that, hey, let me write this down. Okay, if somebody says, hey, the derivative of y is equal x power n, right? This is the derivative, okay? What's its original function? Okay, you understand? So given that, so y is the function, you don't know what is y, okay? Y is unknown, got it? But the derivative of the y is x power n, okay? Now the formula for this is a formula that you got to remember, is y should be equal to 1 divided by n plus 1 x to the power of n plus 1 plus c. Okay, so you don't know y, but the formula says, hey, y is actually, you take the n, do a 1 by n plus 1 multiplied by x to the power of n plus 1 plus a constant. Is this true? Well, the easiest way to find out if this is true is actually find the derivative, right? So if you take the derivative of (1) divided by n plus 1 x to the power of n plus 1, and remember that 1 by n plus 1 is like a constant, plus c, okay? So we know that 1 by n plus 1 will be as is, right? Nothing changed there because it's a constant, okay? It's like a 4 or a 5 or a 15, doesn't matter, right? It's just a constant. Now x to the power of n plus 1, you know that, and I'm going to write this in the end. So you know derivative of x to the power of n is n x to the power of n minus n minus 1, correct? I'm just going to put that formula. Now, therefore, in this case, it will be, so x to the power of n plus 1 means, so you take the n plus 1, that is what is n, right? This n is n plus 1 in this case, okay? And then multiply that by x to the power of n plus 1 minus 1, okay? Because you see that n is n plus 1 minus 1. And obviously, if you find the derivative of a constant, it's just 0. There's nothing there, okay? So in that case, what happens is, first of all, these n plus 1 and n plus 1 cancels out. N plus 1 minus 1 is n, and therefore you know that that is actually x to the power of n. You see that? So if x to the power of n is the derivative, then y is, or the function, the original function is 1 by n plus 1, x to the power of n plus 1 plus c. Okay? So good so far? Okay. And we effectively use this formula to find y. Okay, if somebody asks you, hey, here is x to the power of 15, okay, find y. All we need to do is we need to say 1 by 16, 1 by 15 plus 1, which is 16, then x to the power of 15 plus 1, 16 plus c, right? So you just substitute your stuff with the formula like how you used to do for derivative, and you get the results, okay? No rocket science here. So I'm just going to clear the board. So once we have that, then there are few other things that you got to remember for antiderivatives, right? And this is basically, if you know how to get derivatives, these rules of antiderivatives is also very simple. Okay, the first rule is, so let's say if dy by dx, that is a derivative, is equal to k. Okay, so that means dy by dx is actually just a constant. Okay, nothing there, just a constant. Then what happens is y is actually equal to k of ex, k multiplied by x. Again, very easy to prove, right? Because if you say that, if you take kx, so if you want to find the derivative of kx, okay, and that is equal to a constant, the constant will remain the same, and then you see that x to the power of 1 will be, you take the 1 and the x to the power of 0, correct? That's what will happen, correct? So that is equal to k. You see, so it's very easy to verify that this holds. So if you do dy by dx is k, then the antiderivative has to be kx. That's what we are seeing here, right? Let's try one more thing. I'm going to, in this case, I'm going to use the eraser to rub this off. Let's see. Okay. I just want to prove it, but remember that if somebody is saying that, hey, a derivative is just a constant, then you say, oh, in that case, the antiderivative should be constant into x. Okay, that's what is that formula. Now the next one is, if you say, maybe I'll use a different color, dy by dx, the derivative is k to the power of x to the power of n. Okay, so we know you take the k out, okay, constant doesn't matter. Then you say, and then I can put, because I know x to the power of n, I know the antiderivative, right? It's actually n plus 1 x to the power of n plus 1 plus c. Remember the formula that I gave you. So I'm just applying the same formula. This is 1 by n plus 1. So I'm just going to put k by n plus 1 x to the power of n plus 1 plus c. Okay. Then one more thing, and this is useful in cases where they give you multiple terms. So you got what is the derivative, what is the antiderivative of x power n. We got what is the antiderivative of just a constant. Then what is the antiderivative of constant multiplied by x power n. Okay. Now what happens if you have multiple terms, right? So here is your formula. If dy by dx is, that is the derivative is, equals a function of x plus another function of x, okay, if that is the case, then what you do is that, what is the antiderivative, right? It is basically the antiderivative of x, that is f capital of x, plus antiderivative of, so the antiderivative of the first function, the antiderivative of the second function, plus a constant. Okay, so if you have, like, for example, if somebody is giving you x power x cube plus x square, right? So you find the antiderivative of the first function, then find the antiderivative of the second function, plus you add a constant. Okay, and I'll show you when we do the examples, we can see what that is. Okay, but it's important that you remember these rules. Okay, these rules are quite important. Let me see, it's only 12 minutes, and this time I am strictly going to follow the 20-minute rule, because that way, you know, you're not overwhelmed with some of the things that we are talking about. Okay, so I'm just going to clear this board also. Okay, so now that we know the formula, let's try some sort of equation first and see how it works out. Okay, and then we'll see you know, how we can do this sort of stuff, right? So let's start with simple, if somebody is asking you what is the antiderivative of, you know, I'm just going to come up with some random thing, x to the power of x to the power of 5, okay, minus 4x to the power of 3 plus I don't know, 5x squared minus 7x plus 2. So they are saying basically, hey, dy by dx is that, and they're asking what's y. Okay, so now with the knowledge, we are armed with the knowledge of all the formulas and everything, right? So we start with each term, because we know that we need to do each term, and then there will be a constant, correct? So let's start with, we say that a, you know, x to the power of n formula, right? So that is basically x to the power of n plus 1, which is x to the power of 6 divided by, it is 1 by 6, right? So x to the power of 6 divided by 6, that is the formula. Y, I'm just going to write this down here, is if dy by dx is x to the power of, let me rub this off, x to the power of n, we said, hey, that's equal to 1 by n plus 1 x to the power of n plus 1 right. I want to make sure that that is the formula. Yeah, and in this case, obviously, you are going to have a plus c, right? There is a plus c here, okay? And the only other thing that you got to remember is that, so that all those constants, you add all of them together into one constant, right? So when you say that, hey, there is a plus c, I'm not going to put that plus c in the beginning, I'm going to put the plus c in the end, okay? That's kind of what we ought to do. So it's x to the power of 6 divided by 6 minus 4x to the power of 4 divided by 4, correct, plus 5x cubed divided by 3 minus, so you remember that if it is just, if kx, if the derivative is kx, antiderivative is just k, right? So minus 7, of course the plus 2, there is no antiderivative for it, but obviously there's going to be a plus c, okay? Now you can obviously simplify this. So that is x to the power of 6 by 6 minus x to the power of 4 plus 5x cubed minus 7 plus c, okay? So that's pretty much it, okay? Now I'll refer to the book also, just for you to understand how things are done. And this is one example, I just made it up, but let me see. In the book you have, we make it bigger. So they have another one, x to the power of 4 minus 4x cubed plus 9x squared minus 6x plus 5, right? So then that's what is the function. So you got to find the antiderivative. So for x to the power of 4, they're doing x to the power of 5 by 5 minus 4 into x to the power of 4 by 4 plus 9 into x cubed by 3 minus 6 into x squared by 2 plus 5 becomes 5x plus c, right? And then they're simplifying. Okay, so you just apply the formula and then simplify it. Now I want to make sure that in our blackboard, did I do everything right? I think I made a little mistake. I want to make sure that I correct it, right? So that 7x will actually become, let me do this, because when I saw the book, I realized I made a little mistake, and it's okay, we can correct it. That will be 7x square by 2, correct? Because that was x to the power of 1 plus 2x, okay, then plus c. So again, I want to correct that here, because I don't want you to, when I make a mistake, and you will get confused, why did this guy do it this way? X squared by 2 plus, because that is 2, so remember that the formula dy, if dy by dx is k, then y is equals kx, right? So I forgot that one, so that is 2x plus, I'm adding everybody is having, some of these terms will have a constant, all of those constants together we add one constant plus c, okay? Okay. So, and then I want to show you, let me clear this board. Now they may ask very similar question, slightly in a different way, right? They say that the gradient of a curve is given by dy by dx equals 6x squared plus 8x. If the curve passes through the point 1 and minus 1, find its equation, right? So they're saying that the gradient of the curve. So when you say gradient of the curve, that is a derivative, right? So they're saying the derivative is 6x squared plus 8x. Then they're also giving, they're kind of also adding a little twist. They're saying that if the curve passes through the point 1 and minus 1, find its equation, okay? Then the second thing is that if f double prime of x is equal to 6x plus 2 and f prime of 1 is equal to f of minus 2 equal to 0, find f of 3, okay, function of 3. Okay, so let's look at the formula. Let's look at the solution first. So dy by dx is that. So what is the original function? Then you go back to the original formula, which is 6 multiplied by x cubed, x squared is added to x cubed by 3, plus 8 x squared plus c. So that says 2x cubed plus 4x squared plus c, okay? So then they're saying that, hey, you know, if the curve passes through point 1 and minus 3, find the equation is what they're asking, right? So all you need to do is, you know, y, you substitute y with minus 3, because that is minus 3, and you substitute x with 1, okay? So then you have minus 9 is c. So basically, when they ask questions like this, what you're trying to find out is, you're finding out what is that constant. Once you find out that constant, then all you're going to do is you're going to say y is equals, see here you have just c here, you're just saying, oh, y is minus 9, the constant is minus 9, so you just put 2x cubed plus 4x squared minus 9, okay? So you might be asked that kind of question. Then the second question is, so they do the f double prime, that is double derivative, right? It's a derivative of the derivative, right? So they say that, okay, let me find the double derivative is that, then the single derivative will be, so antiderivative means you're going back one step, okay? Will be 6 into x squared by 2 plus 2 into x plus c, right? So that comes to that. You find the antiderivative first. But then they say that, hey, the antiderivative of 1 is 0. So you substitute that. That gives you a c, okay? So the f single prime of x is, you found out that c is minus 5, so you use that formula, okay? Now again you're going to find the antiderivative, second step, okay, with that information. So then you're adding up that information and you're getting it for, with the instead of c you're using a d, right, just to make, and then they gave you a f of minus 2 0, so you go do that, and then d is minus 6, right? So that then the equation is f of x is x cubed plus x squared minus 5x minus 6, right? So after you find that out, after you found that out, because if you see the question, if f double prime is that, if f of 1 is that, f of minus 3 is that, find f of 3, right? So you finally got the final function, Now you're substituting that with 3 and figuring out what is the answer. Got it? And basically what I will do is, after this 20-minute session, I will go through the exercises one by one. You will understand these. I just showed you how it is written in the book, but I am going to do some exercises, so then you'll get the idea of how to do it, right? Okay, let's see. Okay, it's already 25 minutes. So what I'm going to do is, I'm going to stop here. I'm going to record another video. In the next video, we will talk about what is this chain rule. So there's something called as a chain rule with some examples. We'll go through the examples, and then there is something called as a general chain rule. Okay. So and again, these are all formulas. We just need to understand what these formulas are. If we get an understanding of these formulas, then we can keep that in mind. And then after that, we'll go through the exercises. Okay. So for now, thank you very much. I am going to make another video on the chain rules. Okay. Thank you.